Hi guys, this is a video guide on mastering the tools of NMR Spectra Data Processing. We're going to be using MestreNOVA in this section, and this is a section of a workshop organized by the Department of Pharmaceutical and Medicinal Chemistry, Faculty of Pharmaceutical Science, A.B.U University. Um, we're good to go. Let's start by having a brief introduction to MestreNOVA. MestreNOVA is a spectral data analyzing software that can be run on Windows, Mac OS, and a whole range of Linux distributions. It can process your data, both the 1D and 2D NMR, and the 1D involving proton, carbon, and Dept. The 2D NMR, such as HSQC, HMBC, Noisy, COSY, TOXY, and the rest. It can be fully automatic, and it preserves your data in the background to allow a more detailed processing for the expert users with a wealth of advanced functions. The analysis capability of the software are unmatched. It is very advanced. It uses a very advanced algorithm to process your data without any user intervention. It is user-friendly, and it processes your data and presentation package with many extra filters built in, including the spectral estimation. MestreNOVA comes with many plugins that can make the processing of your spectra easy and smooth. An example of them is NMR Nova. It's a professional way to visualize, process, and report your 1D and 2D NMR data. Here we are going to be using the NMR Nova, the process part of it. We also have NMR prediction. This one is used for prediction of structures from NMR data and prediction of NMR data from your structure. We also have a plugin that is an NMR verify. It automatically confirms the structure of an identity of your compound based on the NMR and other spectroscopic technique that you have run. We also have quantitative NMR Nova. It is a dedicated workflow that is developed to quantitatively analyze your data from manual to assisted or fully automated batch processing. And last but not the least, we have database MestreNOVA. Database MestreNOVA, it attach or integrate a professional database for sharing, storing, and searching your data of structures. We can use computer assisted structural investigation using database MNOVA. Thank you. And this is our reference. Then, first of all, we're going to be working uh, on using MestreNOVA to correct our baseline to monitor our baseline correction. The first thing we should do is have your MestreNOVA app downloaded, put it on your desktop, then you double click on it to open. Um, this is a trial version of the MestreNOVA that we are using, and it's the previous version, and we're going to be using it for our spectra processing. The first thing is how to open an FID file. There are a lot of method of opening FID file. You can use a command. You can scroll to your file to open. When you click on your file, you will see the tab open. When you click on open, it takes you to a directory where you have your FID files in your system. Then also you can use a command. Just click on Control O, that is Control Open. It takes you to the directory of where you have your FID files located. And you can also drag, if you have your FID files already in the folder, you can drag it into your MestreNOVA and it automatically opens all the FID files inside the folder. So now let's use one of the method. For me, I like using the command because it's very fast. So Control O. So after pressing the Control O, allocate. For your information, MestreNOVA only understand FID files. Any extension that is not FID, it's not going to help. It's not going to open. So make sure you have your FID file. FID, the full meaning is free induction decay. It is a file extension that is generated from your NMR machine when you try to run an analysis of a particular compound. So let's navigate to our phase correction FID, an FID file that has a phase correction issue. As you can see, I've opened the FID file after my command. I navigated to the FID file, the folder that is having the FID file. I double click on it, then it opens. So phase correction. When you look at this FID file that has been generated from the NMR machine, we can see that it has the phase correction issue. This is a 1D NMR, that is the Proton NMR. It's supposed to be facing positive, but when we look at it closely, it's facing positive and it's also facing negative. So we are going to correct the phase. The first thing we do correcting the phase is navigate to your processing tab. So when you go to your processing tab, you see a whole lot of phase correction. You can go to the manual, click on magnitude. So when you click on magnitude, you can see that the phase of the FID of the spectrum has been corrected to the positive. So it has been corrected to the positive, meaning that it is back to the corrected phase. The spectrum is a little bit above, so we have to bring it down. So you just um, locate to your processing, to your view tool, then bring your cursor to this fit to height, then you click on fit to highest compound. You can see that the spectrum is now down to the base. We can also fit to highest intensity. So we can see, so the spectrum is down, but to me, I can still see a problem of baseline correction. We can go to processing, go to baseline correction. You choose the polynomial fit. So when you choose the polynomial fit and you click, you see that when you look closely, you see that there is a little bit of shifting on the baseline correction. If the baseline is still not looking so smooth to you, you can always go back. Choose there are like many options there that you can choose. You can choose white smoother. So you can see that there is a little bit of correction in the white smoother option. So then this is how to correct your phase correction and the baseline correction. You have a whole lot of advanced features on the baseline correction. You choose the one that is applicable depending on how distorted your spectrum is. Then the next thing we are going to be looking at is you have to like zoom your spectrum so that you have the particular interface that you need to be working on your spectrum. So the next thing we are going to be looking at is peak picking. Peak picking, now we want to process a Proton NMR spectrum. So we open a Proton NMR spectrum. We navigate to an FID folder having the FID of a Proton NMR. We click on it. The Proton NMR opens. The first thing is, how do we know that this is a Proton NMR? This is a Proton NMR because as we can see, the peaks starts from 0. The peak starts from 0 and it ends at 12. As we can see, Proton NMR, it's from 0. The 0 peak you see is corresponding to a tritetramethyl So the ranges for Proton NMR is 0 to 15, and if it's a carbon-13 NMR, you see it from 10 to 220. So for me, I like zooming into the exact file for me to be able to see everything clearly. So after zooming in, we have opened an FID file. We can increase the intensity strictly by using our scroller on the mouse. If you are using mouse, you can scroll to increase the intensity. You can scroll up and scroll down. Another way is for you to like come to this tab. You can see it here. You can click on it. You see increase. It can be increasing. As you are clicking increasing, it will be increasing the intensity. You can also decrease. Also, you can also decrease. the exact intensity you wish. So that is how to increase and decrease intensity. So the next thing we are going to be doing is to automatically pick peaks. So to automatically pick peaks, navigate to your analysis, the tab that is called analysis. You can click on the peak picking, and you allow the MestreNOVA to calculate. So if you look up here, you see that some numbers has been designated for each of the peaks. One of the disadvantages of automatic peak picking is that when you have a spectrum, a proton NMR, whereby there are impurities or any other form of artifacts that their spectrum is, they are also having a chemical shift, it is going to deposit their numbers designating their chemical shift. These numbers are called chemical shift. So the disadvantage is that the disadvantage is that you have the peaks for the artifact, the impurities, they also have their own chemical shift. So for me, I prefer using the manual pick. So this is an automatic peak picking. So let's undo it for us to have our pick. So the automatic peak picking is gone. So let's try the manual pick. The manual pick. So let me scroll up. So when you want to do the manual pick picking, you just navigate to this tab that is showing the manual threshold. We have automatic, auto pick picking, we have the manual threshold, and we have the pick by pick. These are the three methods of picking picks. So for each of the pick, you can pick them automatically, you can pick them manually, and you can pick them using pick by pick. So when you click on the tab that is having pick by pick, you see the nature of my cursor. It changed to something like this, a plus and an arrow sign. You can come to the pick that you want to pick. Make sure you have zoom it very well so that when you are picking the pick, you are not picking the pick that is responsible for an artifact. So just drop your pick here, drop your cursor here, drag. When you drag, you can see this is a pick. This particular pick has been designated as a chemical shift. Let's undo it again. So make sure the circle you are when you click and drag, make sure it is beside the circle to the other side, and make sure that the height of the peak is a little bit covered. You can see we are covering a particular height down to the peak. So when you release it, it's going to designate a particular number. Let's go for the second one. So that is manual peak picking. For the third one, that is manual peak picking. So then let's zoom in, let's zoom out rather. So for us to be able to locate the other peaks, then we zoom in back. So our peak picking manual. So as we can see, as we are picking the peaks, it's dropping their chemical shift on it. The advantage of this is I can choose which peak I'm going to request the MestreNOVA to give me the chemical shift. So that's the advantage. So bypassing a whole lot of problem, because some peaks might be responsible for impurity, for artifact. As we can see, there are some low line peaks here that their intensity is very short. We can attribute that to impurities. So that is peak picking using automatic and manual. The last but not the least way of peak picking is by using pick by pick. So let us delete the peaks that we have picked. Um, we have deleted all the peaks that we have picked so that we can practicalize the pick by picks method. First of all, I always advise make sure you zoom in to the peak that you want to pick. You zoom in very well, so then you can now go back to your process. Then we can locate the pick by pick tab. When you click it, then in this pick by pick, you'll be locating the peak It's going to be picking your peak according to their multiplicity. Each of the multiplicities are going to be, the cursor is going to be dropping a circle on top of them. So when you see your cursor dropping a circle, just left click, you scroll again, you left click. So let's go for this. It has dropped the circle on top. Click, click only once, click, click, click. So let's go zoom out again so that we can see how to pick our peak using peak by peak. So we go back to our processing, peak by peak. So let's drop a circle, drop a circle. In these features, we have to be very careful with the kind of peak we are picking. We have to be very careful. This is how to pick our peak using peak by peak. Make sure it drops a circle on top of the peaks before you start picking. So you can go on and on using the peak by peak to pick all the peaks you want. This manual picking and peak by picking, it gives you the advantages of bypassing picking a peak that is not necessary for your Proton NMR. When you see this, for example, when you see this now, we can say that this is a very good peak because we can see their height, they are not having a very good intensity. Compared to this, we can normally say that these are very good peaks responsible for this particular compound. So, and this they may be as a result of impurity, artifact, or solvent impurities. So this is peak by peak. So the next thing we are going to be doing is we are going to be looking at integration. So let's zoom out again. We have picked our peaks. So let's practicalize how to bring out how to do the multiplate analysis and integration. Click on your analysis tab. On top of the MestreNOVA tab, you see multiplate analysis and you see integration. You can use automatic integration. You can do manual and can do automatic and manual. So let's look at the automatic. So as we can see from the downside that um, an automatic integration has been calculated for each of the peaks. It's calculated for some, it doesn't calculate for some. So as we can see, it calculated integration for some and it doesn't calculate for some. That was because it may be due to the fact that we didn't pick the peaks. It's only calculated for the peaks that we have picked. This is telling us that any peak that you have picked is the one is going to be calculated, that is going to calculate your integration for. If you is either you have picked the peaks all for it to calculate the integration for all your peaks, or you have not picked them at all. So let's delete all our peaks so that we tell the system to calculate the integration for all the peaks again. Let's see. So as we can see now, for all the peaks, it has calculated the integrations. So it has dropped the numbers under it. This is automatic way of integration. You can zoom back, you see that this integration is telling you that the integration is all about the coupling. Is it the coupling? So the integration is measuring the intensity of each signal or signal peak strength, and is carried out after chemical shift have been assigned or when it has not been assigned. The integration is proportional to the number of protons that is responsible for that signal. A signal that is due to methyl group is going to give you 3 times more intense than the one that is due to a methine. Not there is no absolute scale to this line. It may give you a whole number. So that is about the integration. So how many minutes? Okay. So after the integration, so let's zoom out back. We're going to be looking at multiplate analysis. So the multiplate analysis is all about multiplicity. We are going to tell the MestreNOVA to give you the multiplicity of each of the peaks. The multiplicity is defined as the number of lines seen in a chemical shift. It tells you how many hydrogen atoms are attached to a neighboring atom, and it takes the average of each peak and assign their multiplicities. We have a singlet multiplicity. It is denoted as S, and this implies that this particular peak is having a neighboring carbon that has no proton attached according to N+1 rule. So we can also have a doublet multiplicity, which implies the neighboring carbon is having one proton attached, N+1, and also you can have triplet, doublet, which can be said to be multiplet. So to automatically assign multiplicity, just navigate to your tab, the analysis tab. You can see the automatic multiplate analysis. You can do the automatic and you can also do the manual. You click the multiplate analysis, it's going to give you the average of each of the peaks, the chemical shift. For example, if a particular peak, if it has a doublet multiplicity, it's going to calculate the average and put an alphabet D on the multiplate box. That is showing you that that particular peak is a doublet. Anywhere you see D is a doublet. You can see M, which is a multiplet. You can see S, which is a singlet. You can see D, which is a doublet of a doublet of a doublet. You can see DD, which is doublet. You can see CS, which is a singlet. So these are the multiplate analysis, and this A, B, C, D, E is just a serial alphabet numbering of your peaks starting from A, B, C, D to L. So the ones in bracket are the multiplicities. The next thing we are going to be looking at is to get our J values. Our J values indicates the coupling constant, and it is defined as the spacing of line observed in the multiplicities. It provides information about the position of substituents in a molecule of the compound that we're trying to get. The first way to look at our J value is point your cursor to any peak that is having either doublet, triplet, multiplet, and above. You cannot calculate J value for a singlet because a singlet is a singlet. You can only calculate the distance between two things, not only one thing. So for this particular doublet of doublet, you can just right click on it, edit multiplet, then you see it gives you the first information you see from this a particular box is you see the chemical shift, you see the multiplicity, you see the J values that it has calculated. The J values are in Hertz, and you see the integration like a 1H that you are seeing. These are the J values that it has calculated for you, and you can also see them here. Here is going to give you the whole the J values. It does not approximate it here, but when you come here, it is giving you the approximated value. And close it, go to another peak that is having a doublet or a triplet, or a triplet. You can see that it's giving you their J values in this box together with their chemical shift and their integration. So that is how to get your J values. The next thing we are going to be looking is carbon 13 spectrum. So we can open our carbon 13 FID file. So, so this is our carbon 13 FID file. How do I know that this is a carbon 13? As I said earlier, it's between 0 and 220. How do we know that this is a carbon 13? It's between 0 and 220. So as I said earlier, this is a proton NMR between 0 and 15. So the same way we pick, the first operation we did on our Proton NMR is peak picking. The same thing applies to carbon 13. You always want to use pick the peak. Here, the automatic peak picking is a very good choice because the carbon, this as you're seeing, this carbon is a carbon of a very good compound. As you can see, you um, can also zoom in to see the peaks clearly. You can zoom in. You can increase intensity using the scroller on your mouse. You can scroll up, you can scroll down, and you can also use this increase intensity. You can increase and decrease. So you can zoom out back so that we can see which other peaks we have picked. So any other pick that is not picked, you can either pick it automatically. You can also either pick it manually or you can use pick by pick to pick the picks. So let's delete all the picks and see the manual pick picking. This is a manual tab. So you can drop your box and it will deposit your chemical shift for that particular picks, and you can go on and on to do that. So what we just did was that you come to your analysis, use your manual, put your cursor by the side of the pick, left click, hold it, don't release it, and drag. As you are dragging, it's going to be depositing a pink box on top of the picks. So hold and drag, click, hold and drag. After you are dragging, make sure it has covered the pick that you want them to pick before you release it. Hold and drag. You can go on and pick all the picks you want manually. And also, you can pick the pick using pick by pick. So the pick by pick will be depositing a box on top of your, it will be depositing a cycle on top of your pick. So when it's depositing the cycle, you can just click. So you can go on and on to pick your pick using pick by picks uh, method. You can use automatic, you can use manual, and you can use pick by pick. So thank you. The next thing we are going to be looking at is the 2D NMR spectrum processing. So the first 2D NMR we are going to be looking is HSQC. Before you can process your HSQC spectrum, make sure your HSQC spectrum consists of proton and carbon 13 NMR spectrum. So it is a 2D NMR. It is also called two-dimensional NMR spectrum because you have a peak in first dimension, and you have a spectrum in one direction, and you also have a spectrum in another direction, giving you two dimension. So the horizontal direction is the proton NMR in HSQC, while the vertical direction in HSQC is the carbon 13 NMR. So before you process an HSQC spectrum, make sure you have proton NMR, the proton NMR and the carbon 13 NMR spectra already opened on your MestreNOVA. You can see this is our proton NMR and this is our carbon 13 NMR. Then we go on to open an HSQC FID from the NMR machine. So this is our folder containing the HSQC. This is an HSQC spectrum. As we have click on open, we can see that it has automatically given us it has automatically plotted the proton NMR in the horizontal direction and the carbon-13 NMR in the vertical direction. These are the proton and the carbon-13 spectral data that has been opened on the MestreNOVA. If you do not have any proton or carbon-13 NMR open and you go on to open your HSQC, it is not going to plot, it is not going to correlate the proton and the carbon-13 spectra for you to have the information you need for the correlation. HSQC is just the correlation between the proton and its respective carbon. So the correlation between the proton and its respective carbon. So you can use this plus to navigate to each of the points. You can increase the intensity by simply scrolling. Anywhere you drop the cursor is where it is going to increase the intensity. If you put the cursor here and increase the roller, it is simply going to increase the intensity. So if you click here, it is simply increasing the intensity. So if you come to the middle, put your cursor in the middle, is simply going to increase the intensity. You can zoom in. You can zoom into your spectrums. So then you can also zoom out. So, and also your HSQC, it can plot the it can give you the peaks, the proton corresponding to its respective carbon by simply clicking on the auto peak picking. As we can see, it has automatically plotted the spectrum for you. So as we can see, each of the proton corresponding to its respective carbon has been correlated automatically. You can do it manually. This is just peak picking. You can always navigate back to your peak picking method, the automatic, the manual, and the peak by peak for you to see how peak picking is being done. The same thing goes for HMBC. HMBC is also proton and carbon correlation. The only difference is that in HSQC is on a one bond correlation, homonuclear single quantum correlation, proton to the respective carbon, but in HMBC is a long range correlation between 2 to 3 bonds, heteronuclear multiple bond correlation. Proton is correlated to a carbon 2 to 3 bonds away in a molecule. So the same way HMBC is opened is the same way HSQC is opened is the same way HMBC is also opened, and you can pick your peaks. Picking the peaks means you are telling the MestreNOVA to correlate each peaks for you, the proton to the carbon, as you wish. You can use the automatic, the manual, and peak by peak. The last but not the least we are going to be looking at today is the COSI. So our COSI spectrum is located in folder 13. So this is our COSI spectrum. As we can see, MestreNOVA understands everything you are doing. MestreNOVA understands that in HSQC, it understands that proton is correlated to its respective carbon. Also in HMBC, proton is correlated to carbon. In COSI, proton is correlated to proton. That's why we call it proton-proton correlation. As we can see, this is the Proton NMR that we have opened. We can always increase the intensity using the scroller on our mouse, and we can also always come back here. Anywhere you put the cursor and take activity on your scroller is where it is going to increase the intensity or decrease it. Always bring it back to the middle so that it will increase the intensity of your peaks. So, and you can always do the automatic peak picking and then the manual peak picking. When you do the peak picking, you are telling the MestreNOVA to correlate for you the proton to another proton in a molecule. You can alternatively, you can do it manually, whereby you look for the J value. The J value can also tells you which proton is correlated to another proton. You have an autocorrelation, for example, in a benzene molecule. It means the protons are side by side. When a particular proton is seeing another proton in a course, it means the protons are side by side, and you can also confirm this by calculating the J value. The J value is around 7 to 8, 6 to 8 in some cases. You can see it is autocorrelation. If it's between 2 or 1.5 to 6, that is meta correlation. We can also call it 1-3 correlation. If it is auto, it is 1-2 correlation. Then using in the J value, if the J value is 0 to 1.5, that is the para correlation in a benzene nucleus molecule. That is about quasi correlation. Also, lastly, you can always generate a report. You can always generate a report for for any data you have processed by simply coming to your analysis on any of the spectrum. Come to analysis, then you come to a tab called generate report peaks. So when you click on the report peaks and come to the carbon, click on the report peaks to give you the list of all the carbon spectrum. So you can always come to here, click on report to give you the report of all the peaks. So this report, don't always rely on it, because sometimes it might be right, sometimes it might not, because so your report consists of this is telling you that you have a report of carbon 13 NMR. So let's try to shift it down so that we can see it very well. We can see this is a carbon 13 NMR. It's telling you that it is a carbon 13. It's giving you the next information you are seeing there is the capacity of the machine. The next is you can see CDCl3, that is deuterated chloroform. This particular compound is around in chloroform, and it goes on to arrange your peaks in descending order of magnitude. The first peak there is 146, 145, 132, 119. You can always copy this to and use it any other places you want to use it. You can copy it to your Microsoft Word, to any other document that it might be useful for you. You can come here, click on your report peaks. These are the data of your Proton NMR. As you can see here, it tells you that this is carbon 13 NMR, right? So, but here it's telling you that this is a Proton NMR. We can see the difference. So this is a Proton NMR report, and this is carbon 13 NMR report. You can see the information there, as we said earlier, the capacity of the machine, the solvent used, this which is chloroform, and it goes on to arrange your peaks in descending order of magnitude, starting from 7.0 to the last one, which is 0.02. So now then, these are still in an FID file format. When you are done with processing your peaks, you pick your peaks, you do the multiplicity, you do the integration, you do the multiplate analysis, you calculate your J value. You can always, after finishing processing your peaks, your spectrum, your spectral data, you can always save your spectra in any format you use. Preferably, you can use the PDF format, and you can use the PDF format, and you can also use any other format you want. How do we do that? So just navigate to your file. You can see export to PDF. When you click on export to PDF, it tells you what name do you want to save your file with, and it has given you the file format here, the file format. When you are done naming your compound, you click the location where you want it. For me, let me click on desktop. I want the file format to be MestreNOVA. Then when you click on save, then this is another option you have. The MestreNOVA tab app will ask you whether you want to save the whole document. This task panes you have here, we have three task panes here. Um, it will ask you whether you want to save your current page, your selected page, or you want to save the whole document. So let's save the whole document and click on OK. Then you can always go back to our document. We can see here on the tab that it has converted to the spectrum to PDF file format for us, and you can always use it. So the next way to save your file is you can go to Save As. So in Save As, you can choose which kind of what kind of file format you want to save it with. You can save it to MestreNOVA, the FID, the BMF. You can also save it with a JPEG picture, the PNG, so that to save everything with a picture. So let's put it as MestreNOVA. So I choose the JPEG file saving format. Click on send. You can see. Thank you very much for listening to our session. This is how far we can go on this section of using MestreNOVA to process our FID data. Um, you can always contact us for any other information you need from this our YouTube link. You can drop your comment, click on the like button and subscribe so that whenever we drop any video, you